Good morning, dear student. In previous lecture, we already discussed the non-Portland cement, that is high alumina cement and the phosphate cement. One more is remaining, so you try to find out the information regarding to this calcium sulfur aluminate cement. So in today's lecture, we are very much interested in the important topic of our chapter, that is cement hydration. So, what is the cement hydration and what is the reaction in the cement hydration? We will discuss in this lecture. Cement hydration, if you consider its definition, it is nothing but, so the first point regarding to the cement hydration, the chemical reaction takes place chemical reaction take place between between cement and water. Cement and water is refer as hydration is refer as hydration. So the chemical reaction takes place between cement and water is refer as hydration. Okay. uh, Another point is that this reaction, that is the reaction between water and cement, is an exothermic irreversible reaction. So we can write series of irreversible exothermic reaction, means heat is given out. Okay, so series of irreversible exothermic reaction between cement and water, it is also called the cement hydration. So in other words, we can say that is in presence of water, the silicates such as C2S and C3S, dicalcium silicate and tricalcium silicate, and aluminate that is tricalcium aluminate and tetraaluminate ferrite forms product of hydration forms the product of hydration which in time which in time produces a hard mass which is known as hydrated cement paste. A hard mass which is known as hydrated cement paste. So these are the some important points regarding to the cement hydration. The chemical reaction takes place between cement and water is referred as hydration. Series of irreversible exothermic reaction between cement and water. So whatever the reaction between cement and water is irreversible and it is exothermic, means a lot of heat is given out. So in presence of water, silicates such as dicalcium and tricalcium silicate and aluminates, that is such as C3A and C4AF, forms the product of hydration, which is in time produces hard mass. It is known as hydrated cement paste. So to discuss the reaction of the silicates with water. Discuss the reaction, that is the first one, that is hydration process of C3S, tricalcium silicate. Hydration process of C3S. So if you consider the reaction, it is two molecules of this tricalcium silicate are react with 6 water molecule, and there is a formation of this TriCAO twice SiO3 and 3 water molecule. It is known as calcium silicate hydrate. Calcium silicate hydrate. So this is the reaction, that is tricalcium silicate. So this is your tricalcium silicate. Tricalcium silicate react with water and formation of calcium silicate hydrate plus thrice calcium hydroxide plus thrice calcium hydroxide. So if you consider the role of this C3S, this C3S, that is tricalcium silicate, hydrates rapidly and forms earlier strength of concrete. So it C3S, it hydrates rapidly. C3S, it hydrates rapidly. And if you consider the second point, that is uh, it produces produces it produces more amount of heat, more amount of heat during hydration process. During hydration process, so it hydrates rapidly and it produces more amount of heat during the hydration process. Again, one more important point is that the cement with more content of C3S is better in cold weathering concreting. So we can use it in cold weather concreting when the cement containing high concentration of C3S, that is tricalcium silicate. So this is the reaction, that is tricalcium silicate react with water and there is a formation of calcium silicate hydrate. Let us discuss the second reaction, that is hydration process of dicalcium silicate. Hydration of C2S, dicalcium silicate. So two molecules of this dicalcium silicate react with 4 molecules of water and there is a formation of again calcium silicate hydrate, that is CaO SiO2 thrice water molecule plus calcium hydroxide, 3 molecules of calcium hydroxide. So this is your calcium silicate hydrate, calcium silicate hydrate. Again, if you consider this C2 is slowly hydrates slowly as compared to tricalcium silicate, and it is responsible for progressive strength of the concrete. progressive strength of the concrete. The CTS, if you consider the third point, it produces less amount of heat during hydration process. During hydration process. And the next important point is that it is responsible for measure strength of concrete. Measure strength of concrete. So whenever these silicates react with water, the formation of calcium silicate hydrate with formation of calcium hydroxide. Okay, and this if you consider the dicalcium silicate hydrates slowly as compared to the tricalcium silicate, and it produces less amount of heat during the hydration reaction, and it is responsible for major strength of concrete. If you consider this process, that is hydration reaction of this cement, so which results into the formation of calcium hydroxide as a product. So this reaction, if you consider, no doubt, along with hydrates, that is calcium silicate hydrate, calcium silicate hydrates and calcium aluminum hydrate, there is a formation of calcium hydroxide. One of the product of hydration of C3S and C2S, that is tricalcium silicate and dicalcium aluminate, not aluminate, tricalcium silicate and dicalcium silicate is calcium hydroxide. So it is our byproduct, and this calcium hydroxide, so what it causes, if you consider the product of this hydration is your calcium hydroxides, the lack of durability of concrete, is an account of the presence of calcium hydroxide. So this calcium hydroxide is one of the product of this hydration reaction of dicalcium silicate and tricalcium silicate, and the lack of durability of concrete is an account due to the presence of this calcium hydroxide. So why this calcium hydroxides decreases the durability? Okay, lack of durability of concrete is due to the presence of calcium hydroxide. So this calcium hydroxide react with the sulfate present in water and soil. Okay, this calcium hydroxide react with sulfate present in water and soil, and to form calcium sulfate. And this calcium sulfate further react with your tricalcium aluminate and causes deterioration of concrete, and this is known as sulfate attacks. So the durability of this concrete is decreases. The lack of durability is due to the presence of this calcium hydroxide. This calcium hydroxide react with sulfate present in water and soil to form calcium sulfate, and it will attack on this concrete material, and it is known as sulfate attack. Again, we already discussed the use of blending material. Okay, so in blended cement, The use of blending materials such as fly ash, silica fumes, and other pozzolanic materials are step to overcome the sulfate attack. So whatever the effect of this calcium hydroxide, or it is also known as sulfate attack, okay, it causes the deterioration or destruction of the concrete material. And to avoid this destruction or deterioration of this concrete material, you have to use blending materials such as fly ash, silica fumes, and other pozzolanic material to overcome the sulfur attack. Okay, so this is also the important point. Let us consider the third reaction, that is hydration of C3A. Hydration of C3A, that is tricalcium aluminate. So 3 tricalcium aluminate react with water, and there is a formation of calcium aluminate hydrate. Calcium aluminate hydrate. Calcium aluminate hydrate. Calcium aluminate hydrate. So if you consider this calcium aluminate hydrate hydrates rapidly about 2 to 5 degrees Celsius. It produces large amount of heat. Produces large amount of heat. Produces large amount of heat during hydration process. During hydration process, it is not contribute to the strength of concrete. To the strength of concrete. To the strength of the concrete, but it will give the durability of the concrete. It will give durability of the concrete. Durability of the concrete, because there is no formation of this calcium hydroxide. So we already discussed the lack of durability of concrete is due to the presence of calcium hydroxide. So whenever the reaction of water with tricalcium aluminate, there is a formation of calcium aluminate hydrate. Okay, and in this case, if you consider the reaction, it is gives only the calcium aluminum hydrate. The reaction is not containing the calcium hydroxide, and therefore it will gives the durability of the concrete. Again, let us discuss the fourth one, that is the hydration of this C4AF. Hydration of C4AF, that is tetra calcium aluminoferrite. It is 4CaO Al2O3 Fe2O3 plus water, and it will give 3CaO Al2O3 6H2O plus CaO Fe2O3 H2O, that is calcium aluminate. Okay, calcium aluminate hydrate. And if you consider this, the important point, it shows higher resistance to the attack of sulfate. Shows higher resistance to the attack of sulfate. Attack of sulfate. So this is all about the hydration reaction. So at least you should know the definition, what is the hydration reaction, and then the reactions of this dicalcium, tricalcium, silicate and aluminate with water, and you should know the role of this calcium hydroxides, it how it is attack on this concrete material, and how we overcome the sulfate effect, sulfate attack, by using blending material. So this is the reactions regarding to this hydration of cement. So you find out the process, that is mechanism of hydration, either it is direct hydration or hydrolysis reaction, and different steps in this hydration reaction. So at least we discuss about the reactions of the silicates with water, and it is called as hydration reactions. Okay, in next lecture we will discuss some important admixtures such as plasticizer, set retarders, and accelerator used in the cementitious material. This is all about the hydration. Thank you.